Hello everyone. In the previous session, we have started the discussion of different mathematical operations on discrete time signals. And under this particular topic, we have discussed signal addition, signal multiplication, and amplitude scaling or scalar multiplication. In this particular session, we will cover one more mathematical operation, that is time shifting operation on discrete time signal. So basically a time shifting operation is divided into two types. The first one is time advance operation and the second one is time delay operations. So let us discuss this particular topic one by one. So what exactly a time shifting operation? So basically time shifting is the shifting of a signal in time. This is done by adding or subtracting a scalar k quantity to the time variable n in the function. So basically a time shifting is a shifting of a particular signal either to the right or to the left. So depending on whether it will move right or it will move left, it is divided into two types. The first one is time delay operation, which is x of n minus k. That means the quantity k is subtracted by the time n, and time advance operation, which is x of n plus k, where the quantity k is added with the time n. So in time delay operation, subtracting a fixed positive number, we generally subtract a fixed positive number from the time variable and it will shift the signal to the right by the subtracted quantity. So basically here the subtracted quantity is k, so the signal will move to the right by the k unit. Okay. Now whenever a signal is moving right, that means we can say the axis is moving left. That is why this particular signal is called time delay operation, as the axis is lagging behind the signal. That is why this particular operation is called time delay operation. In the same way, adding a fixed positive number to the time variable will shift the signal to the left by the added quantity. Once again, the added quantity is k, so the signal will move left. Now when a signal will move left, we can say the axis is moving right, or you can say the axis is advances to the signal. That is why this particular operation is called as time advance operation. Now let us understand this concept with few examples. So we have taken an example of a continuous time signal here. You can see the first figure is the original signal, where this is x-axis is my time axis and y-axis is my amplitude axis, which is x of t. This particular signal has an amplitude equal to 2. And this particular signal has a range from -1 to 1. Now let us apply time advance operation. X of t plus 1, which is my time advance operation, and you can see the signal is moving left by 1 unit because the added quantity is 1. Now you can see here in the original signal, it has a range from -1 to 1. Now when we plot x of t plus 1, the new range is from -2 to 0. Now let us understand the concept by some other method. What we will do is that, so as we need to plot x of t plus 1, what I'll do, I'll take a range from -1 to 1, which is my original range, and I'll write here t plus 1. Now for t, this range will be -2 to 0. So my new range for x of t plus 1 will be from -2 to 0. So this is the reason the signal is moving left to the axis. Now let us plot x of t minus 1. As you can see here, as the subtracted quantity is 1, the signal will move right by 1 unit. Now you can see here, my new range is 0 to 2 and my original range was -1 to 1. Now let us understand this concept by the same way we have discussed x of t plus 1. Simply write down the range from -1 to 1, write down the time for the modified signal t minus 1. Now if t minus 1 lies between -1 to 1, I can say t lies between 0 to 2. So my new range will be from 0 to 2 and this signal will be here between 0 to 2. So basically during the time shifting operation, it may be time delay operation, it may be time advance operation, the shape and size of a particular signal never change. Only the shifting of the signal occurs either to the right or to the left of the axis. Now let us understand the concept by the help of one discrete time signal. As you can see on the screen, we have a signal, and this particular signal has a time axis in n and amplitude axis as x of n. Now it has three amplitude, one is at -1, one is at 0 and one is at 1. So at -1 and 1 I have an amplitude of length 1, at 0 I have an amplitude of length 2, and this particular signal has a range from -1 to 1. Now let us plot x of n plus 1. Now you can see, the moment I would like to plot x of n plus 1, the signal will move left by 1 unit because the added quantity is 1. Now the new range for this particular signal will be from -2 to 0. Now let us understand the concept in other way. As my new time is n plus 1, n plus 1 lies between -1 to 1, where -1 and 1 is my original range. So n will be between -2 to 0. Now you can see here that the signal is between -2 to 0. Let us plot x of n minus 1. So as per the definition, the signal will move right by 1 unit because the subtracted quantity is 1 unit. So the new range is from 0 to 2. Now let us understand the concept in other way. My new time is n minus 1. The original range was -1 to 1. N will be 0 to 2 for my new signal, for my modified signal. So you can see 0 to 2 is my new range. So this is how the shifting mechanism occurs in case of shifting operation. Basically, this particular topic is very important for the semester examination point of view as well as for the gate examination point of view. And it is better to remember the right shift and left shift mechanism instead of this particular concept. Thank you.